Welcome back. This is a solution to problem 1C from our 6th quiz of the semester. This is another find the limit of a sequence problem, only this one looks a lot more complicated than the problems from parts A and B. Um, on the other hand, one might look at the numerator of this fraction and see a sine function and go, hey, wait a second, I know sine just oscillates between -1 and 1. This is probably just going to be diverges, right? As soon as I see a sine, I know it can't converge to anything because it's just going up and down and up and down. But we have to be a little careful. Can't be too hasty here because even though it is true that sine is going to oscillate between -1 and 1, it could be that other parts of the function defining the sequence are going to dominate the sine, right? So that maybe that variance looks more like a guitar string, which after a while dampens to the point where it doesn't matter that it's going up and down, it's still converging back to zero, if you like. So let's take a look at the entire thing. So yes, it's true, sine is oscillating, right? You can make n go to infinity in this nice quadratic. We know it'll be an upward facing quadratic. So as n goes to infinity, this quadratic will go to infinity, and sine will just keep oscillating up and down, up and down. But let's look at the bottom. This is also a nice polynomial and has a positive leading coefficient. So we should expect that as n goes to infinity, this polynomial should also go to infinity. Okay, well, we can actually verify that. We don't just have to suspect it. So we could make the following argument. 5n cubed minus 4n squared plus 6n minus 7. I could rewrite that by factoring out an n cubed. So I'd have n cubed times 5 minus 4 over n. Okay, let's double check, right? I had two n's here, right? An n squared. So when I factor out an n cubed, I have to get a divided by n. All right, if I distribute, you see n cubed over n becomes n squared again. All right, plus, let's see now, it'll be 6 over n squared, because here I just want to have one n. And then finally, 7 over n cubed. All right, now these 4s, 6s, and 7s don't really concern me too much. We know we can pull those outside of a sequence. And I was, again, told I can assume without proof that 1 over n to the k for any positive k, and here we have k equals 1, 2, and 3, those sequences converge to 0. So as n goes to infinity, all three of these terms will go to 0. So I get this entire piece converging to 5 times n cubed, and n is going to infinity. So I'm taking something going to infinity and multiplying it by something which is converging to 5. So as n goes to infinity, this whole thing is going to blow up to infinity. Okay, so now we can go back here and be sure that, okay, yes, this numerator is oscillating between -1 and 1, but the denominator is getting enormous, which should mean that this entire sequence is getting really, really tiny as n grows large. All right, so our suspicion is that this is actually going to converge to 0. How could we prove it? Well, whenever sine is involved in these, it's a good idea to check out the squeeze theorem. So let's write down maybe what the squeeze theorem would tell us. So first, okay, we should say something about the sine function. So we know that the sine of this quadratic is bounded above and below by 1 and -1. Okay. And once I get this n to be big enough, I know that this polynomial is blowing up to infinity. And so it's not going to change sign. So for large enough n, I can multiply through by 1 over this polynomial, and it's not going to change the signs any. So for large enough n, so for large enough n, I'll get -1 over, okay, this whole polynomial, which I really don't want to copy all of it down. So let me just give a name to it. I'll call it g of n since it's on the bottom. Okay, so negative 1 over g of n is less than or equal to the sine. Okay, well, I guess I could have given a name to this too, so I don't have to copy it. Divided by g of n is less than or equal to 1 over g of n. However, the nice thing about these left side and the right side is that we know that the denominators are going to infinity. So negative 1 over g to the n, as n goes to infinity, so does g of n, and so the quotient is going to go to 0. Okay, there's a negative. That doesn't bother us. And the same thing on the right. As n goes to infinity, g of n goes to infinity, and so 1 over g of n goes to 0. And so by the squeeze theorem, since this is bounded above and below by two things which are going to 0, the squeeze theorem tells us that the middle also has to converge to 0. And so our function c converges to 0.